Hello, welcome to my video about the integration of a smart garage. Let's first have a look to the layout. In the house, 3 owners have a garage here in the basement, and each garage have a door which can be opened with a remote control. For each door I have a contact sensor installed, so it's 3 contact sensors for the 3 doors. For 2 of the motors I have integrated the remote control into my smart home system. And I did that using a Raspberry Pi. Let's have a look into how I've done that. So I've taken a spare remote, opened it and took out the circuit board. The circuit boards from the 2 remotes I mounted into the cover of a Raspberry Pi and connected it to the Raspberry Pi. When you press the button on the remote, you actually press that mini button here. And as you can see here in the zoom, I soldered a cable from a GPIO pin to the switch here, so I can simulate pressing the switch with the GPIO of the Raspberry. Here at the top you see the harness for the 3 contact sensors which detect open or closed status of the door. How did I do the layout of the connection of the interface? There is a very obvious way to do it. The remote has a battery. You don't want that anymore. You don't need that. So you permanently connect the minus and plus to the Raspberry Pi minus and plus. The voltage is perfect. 3.3 volt is the voltage of the battery. 3.3 volt offered by the Raspberry Pi. And then you connect the GPIO pin to the mini button and it's a done deal. No, it's actually not. It's a big risk because if there is a software problem, if there's a hardware problem here inside the P, if there's a short circuit somewhere, whatever incident may occur caused by Murphy, it may open your garage door. And if that happens late evening, it will not be detected. The garage door may stay open all night, and the next morning you may be missing some items. So that's not a good idea. I didn't even try that. Actually, I've been working with engines, and the starter motor on an engine also has this kind of risk. If the starter is accidentally activated, the car may suddenly jump for a meter and may injure a person. In order to avoid that risk, starter motors have a special security concept. For the starter motor, the plus and minus terminal are both not permanently connected, but connected through a switch. And before they are connected, the ECU of the car will test the 2 cables for short circuits and things like this. And only if everything is okay, the starter will be activated. I transferred this concept, security concept, to the Raspberry Pi and the remote control. So I permanently connect the plus pole, but the minus is going through a switch, and the data signal is going through the switch. So instead of 1 output, I need 2 output pins from the Raspberry Pi. Here I'm using a transistor because I assume that the current required by the remote control exceeds the limit of the GPIO pins. I haven't tested that, I haven't calculated it. Using a transistor is not that difficult, so I just went the safe way. Here, when the output pin is low, the current cannot go through the transistor. So it's isolating, and the voltage of that connection is undefined. So here I have an input pin detecting the voltage here on that connection line, and if it's isolated in the transistor and here undefined, I have a pull-up resistor here on the input pin. So if that is undefined, the pull-up resistor should set the input to the up signal of the TTL logic. In case there is a short circuit somewhere or a software malfunction or whatsoever, and here a ground, a low signal is detected, then this is an error because if this is low, this should be high because of the pull-up resistor. And if it's not high, something is wrong, and the software will simply exit and not do anything anymore until the problem is understood and solved. For the data signal, the principle is the same. Actually, the button connects the electronics to ground, to minus pole. So here, the ground, the low level, simulates pressing the button. So when I set the output to high, I check with the second input pin whether it's really high. If again here there is a short circuit, if setting it to high didn't work for a software bug, for a hardware problem whatsoever, and hasn't been executed, I will see that on the input pin, that I did set it to high, but it didn't turn out to be high. So again, this is inconsistent, this is a problem. The software will exit with an error and not do anything. So only if both are in the good way before doing something, then the software will proceed. It will first connect the remote to the ground, the minus pole, to activate it. And then some 10 milliseconds later, the data signal will be set to low and trigger the remote control to activate the motor to move the door. After doing that, the data signal is returned back to the high level and the transistor is switched off for isolation, and again is checked that here pull up to high has been found and here setting the output to high is also found. So that's the security system on activating the remote control and avoiding that a software bug or a short circuit or a hardware problem accidentally opens the door. There's a second item. You remember the contact sensors I have in the garage for the door connected to GPIOs. So in case the GPIO tells the Raspberry Pi the door of the garage is open too long, for example 10 minutes, 20 minutes, then an alarm is issued for somebody to take care, have a look and close the door. Also for this, I introduced a security aspect. I designed the system in a way that I usually get a false open if there's any kind of problem. So if there is a false open, I have to walk down and check it, and I see it's announced to be open, but physically the door is closed. So I'm forced to look for the problem and solve it. I did design it implicitly in a way that a false close, which would not give a notification, would barely happen. So that's important for the security of that system. Prefer false open compared to false close. What is the experience with that? In the beginning, of course, there were childhood diseases and they were solved, especially because for any problem, the software simply exits and holds. And that creates a pressure you need to identify the root cause and solve it and test it in a good way. Now, after 5 years of using that, the neighbors like it very much and use it very often. There are also some bicycles here where people move it out of the garage and go in and out. Some, if they have some heavy load to carry, it's more convenient to take this way. Those people use it. So several people use it, and if it's not working, I get a text message fairly quickly. So that's the theory. I have prepared a little movie to show it to you and make you understand better how it's working. So here you see the garage door closed. You see the web interface, and here you see a zoom of that area up here. Here you see some wires, and that actually is part of the contact sensor, the read sensor for the magnet, detecting open and closed. In the web interface you see the 3 garage, 1 without button to activate the motor, and garage 2 and 3 with activation of the motor. So when I go through it, here you see I click the button on the web interface, and sometime after that, there we go. You see the garage starts to open, and you see that here it's open, and that is the consequence of the contact sensor up here in the top left corner. You see here a simulation of what percent open the garage is. It's of course not very accurate, but it's good enough to get an understanding about the position of the garage. So garage move up, then I moved it down again. And then in a second it will be interesting to see. There we go. Here you see the contact sensor, the read switch, and in a second you will see the door approaching it. There we are. Here's the magnet which activates the contact sensor. Here you see it's still open, and when I go further, the contact sensor here is the point it gets close enough, and then you see on the web interface the garage is physically closed. Yeah, so this is how it's working, and you can remotely check the status, and the contact sensor is very reliable. The simulation also shows you online. You see here the figure changing, that the door is moving, so it's a very transparent system. Thank you very much for listening. In case I made you curious about my wiki, which I presented here, you will find the link in the description below and in my channel. Thank you very much for listening and watching. See you again. Bye.